In this problem, we're going to be applying the concept of the hydrologic budget to a problem in which we have a pond or a lake, in this case with an area of 300 acres. And over a 30-day period, we have the following information. We know that we have 15 cubic feet per second that flows into this lake. We have about 13 cubic feet per second that flow out of the lake. The lake usually gains in storage about 16 acre feet during that 1 month or 30-day period. In this particular example, for the month that we're looking at, they had precipitation of 1.3 inches. And we are going to assume that ING, right, the infiltration into the soil, and G, which is the flow in the aquifer, are insignificant, that they're not. Of course, there are some values, but we're just assuming that numerically their values are very small relative to the inflows, the outflows, the storage, and the precipitation. And what we want to know is, over that 1 month period, what did we have in terms of evaporation? Now, the key to any of the hydrologic problems, of course, the budget problems, is converting all these different units into the same set of units. And what we usually do is we convert everything to depth. So for example, these flows in CFS will convert to depth. The storage in acre feet will convert to depth, and so forth. Precipitation already is in depth, okay? But that'll be the process. So I'm just going to start by item going through and converting all these units into the right units, okay? So for inflow, okay, I've got, let's see, 15 cubic feet per second, okay, over a 1 month period, okay. And then we just start going through and saying, okay, in a month, let me switch markers here, that one's a little squeaky. We have 30 days. Okay, so the commands cancel. In a day, we've got 24 hours. Okay, so my days cancel. In an hour, we have 3,600 seconds. So my hours, let's see, right here's hours, and we've got seconds and seconds. Okay, so let me make sure we've got the infiltration. That gives me the inflow of this. And we're going to take this and we're going to divide it by 300 acres, okay? So right now in the numerator, I have everything in terms of cubic feet. So what I want to do is get the denominator in by square feet, and then I can divide that out. I'll have a depth in feet, and we can convert that to inches. So we have 30 acres. One of the main conversions that we use in this class, and we use this all the time, is that in an acre we have 43,560 square feet to an acre. Okay, so again, when I do this, that leaves me the denominator square feet. I have cubic feet in the numerator. And what that does is that gives me a final value of my inflow. It comes out to be 2.975 feet, okay? Or in inches, that comes out to be 35.70 inches. Okay, so I converted everything into depth for the inflow. So that's this value here. I'm going to do the same thing for the outflow. Of course, in this case, I'm not going to worry so much about writing all the units out. I'm just going to do the same conversion. So you have 13 times 1 times 30 times 24 times 3,600. Again, everything else is the same, and you divide that by the 300, and then the 43,560, and we get, for depth, we get 2.578 feet, which in inches is 30.94 inches. Okay, so here we've got that. One more thing for the storage. Okay, we have 1,600 acre feet. Okay, that's a volume, right? So we're going to take that and we're going to divide that by the number of acres that we have, which is 300 acres. Okay, that'll give us feet, and then we'll convert feet into inches. okay? And that gives me a storage comes out to be 0.64 inches. Okay. So we've got all this in inches and we're ready to rock and roll. So for us to do our balance, the main equation is that the change in storage is the sum of all the inflows minus the sum of all the outflows, right? So we're just saying whatever storage change we have for this lake is just the sum of everything that's flowing into the lake minus everything that's flowing away from it, okay? So for the inflows, of course, our first inflow that we have the 35.70 inches. Okay, that's an inflow. What else is flowing into it? That would be precipitation. Okay, precipitation in this case is 1.3 inches. Okay. Those are the only things we have, so just going to do a double check here to make sure I'm getting all these values. So that's what's flowing in. Okay. Minus, and then we're going to talk about what's flowing out. Okay. We have an outflow here of 30.94 inches. Okay. That's our outflow. Now, normally, again, we would say, well, you know, we've got the inflow of flow going into the soil beneath it, right? The inflow, we have groundwater flow, and we have evaporation. And as I mentioned earlier, we are going to assume that the inflow and the groundwater flow are zero. No, they're technically not zero, but they're very small relative to all these other values, okay? And we know our storage is 0.64 inches, okay? So all we have to do now is basically just solve, right, with knowing the left-hand side, just solve it with the right-hand side. I get one more thing. I get 0.64 is equal to 6.06, right? All these minus that comes out to 6.06 minus the evaporation, or evaporation comes out to a final value of 6.7 inches. So again, to reiterate, what we did is we looked at this problem, we looked at all the inflows and the outflows. The key was converting everything into the same units because we had cubic feet per second, we had acre feet, we have inches, and we can't add apples to oranges. So we have to convert everything into the same units, which we did of units of depth. In this case, it was inches. So I converted the inflow, the outflow into inches. I took the change in storage and converted that into inches. And then I just essentially used the hydrologic budget equation, in which the change of storage is the sum of the inflows minus the outflows. And we found that the evaporation in this example over a 30-day or 1 month period was 6.7 inches. And that concludes our example of the hydrologic budget.